Hello, SAM fans, and welcome to this SAM Science Physics edition of IV components and graphs in the topic electricity. So this is suitable for Edexcel and AQA, and it should be for OCR as well, both foundation and higher content. So for the higher content, you just need to know what the graphs are in terms of what to look out for in the exam. But whereas for higher content, you need to be able to interpret the graphs, recognize what they look like, and of course you need to know their components as well. So before we start, I thought we might as well start off with a meme here. Why did Mr. Ohm marry Mrs. Ohm? Because he couldn't resist. You get that? Because resistance is measured in ohms. Yeah, if you didn't know what resistance was measured, you need to go back and look over what resistance is and what it's measured in. Okay, right. You should know this already. You should know what the symbols are for the different types of resistors. So you've got your normal resistor, which is a rectangle with two lines on either side. But then the other three types of resistors, along with a variable resistor as well, you've got your LDR, which we'll look at what they are in a moment, your LED, and you've got your thermistor. Okay, so these are types of resistors within themselves. So you need to be able to recognize what these symbols look like. You need to know which ones they are, because a lot of students get confused as to what they are, and you need to know what they do as well. Okay, so this graph here you should see on the right hand side is a very familiar graph that you should be familiar with. So this is a normal resistor. This is what a graph would look like with a normal resistor. As you can see there, it's a rectangle with two lines either side. So this is for a fixed resistor at a constant temperature, meaning the temperature doesn't change, it doesn't get any higher, doesn't get any lower. The graph shows current is directly proportional to potential difference. So what that means is as potential difference increases, current increases proportionate. Okay, so you can see there, if you look at the yellow line going straight across, it's proportionate to the other component. Similarly, as current increases, potential difference also increases. Okay, so you can see it's a nice straight line going across. You can say it's a positive correlation, so that's directly proportionate. Okay. This one here is for a light bulb, so it's a filament lamp. Okay, so this can be for varying temperature, and you can tell because of the curved line. So this is telling us as temperature increases, so does resistance, and this affects the shape of the graph. So you can see here, as the moment it starts to change, you can see it starts to curve over. Okay, and this is similar to, or this is how a filament lamp would work. You can see it kind of looks like it's going proportionate, but then it starts to curve over. So you can see there, current starts to sort of break off, if you like, and current starts to it reaches its optimum level. So you can see that it no longer increases, instead it starts to plateau. And you can tell that because the curve is at the top here. And if the filament lamp was to continue to stay on, then what would happen is that the curved line would then turn into a horizontal line going across. Okay, so current would no longer increase, but all the while potential difference would continue to increase. Okay, so a good way to remember this in an exam is just think of it as an S-shaped curve. Okay. Then we've got your diode. So diode, if you didn't know what a diode was, it's a component that only allows current to flow in one direction. Okay, depending on where you put it in the circuit. So the resistance here is very high in the other direction. So because resistance is very, very high, the current's got no option but to go in the other direction where it's less high, meaning current can flow through nicely. Okay, so as you can see here, you've got a white horizontal line going across, and then what happens, it just sharply increases. So you can kind of, yeah, it's almost like an angle, isn't it? So across, and then the moment diode is implemented into the circuit, you can see the current sharply rises, and you can see there along with the potential difference as well. Okay, so just bearing in mind that diode only allows current to flow in one direction, and that's because resistance is quite high in the other direction, hence why the current's got no other option but to go in the opposite direction of that. Okay, so you do need to be familiar of these different types of graphs, and for higher content you may be asked to draw these. They may give you the axes and then they'll ask you to draw it, so you've got to be prepared to draw it. Okay, time for a meme. LDR, Long distance relationship, no. Light dependent resistor. That's what that LDR stands for. Obviously. Obviously, LDR stands for light dependent resistor, not long distance relationship. If you thought it standing for long distance relationship, you're obviously wrong. According to Drake, you're obviously wrong. Okay, right. These graphs you may be asked to draw as well. So let's pop these up. So you've got LDR, which is light dependent resistor. So what that means is that it's dependent on light for it to work. So as resistance decreases when light intensity increases. Okay, so examples of these uses are, for example, anything that's light censored. Okay, so that could be even something as alarm clocks as well. Like in your home, you've got your alarm clocks. That can be light dependent as well. Street lights are light dependent. You'll notice that street lights, they only come on at certain times of the evening. It's usually perhaps around just after sunset. That's because the light has pretty much gone. You've got other things can be burglar alarm circuits as well. So these where these components are. So resistance decreases when light intensity increases, and you can tell by the graph here. Okay, it's a downward curve. Okay, so as light increases, the resistance decreases. And the other graph that you've got is a thermistor. So thermistor is pretty much a resistor where resistance decreases when temperature increases. So that is a very, very similar line as well. You can see they're pretty much the same. You just need to remember the axis at the bottom there. So amount of light for your LDR, which will measure light dependent resistor. And then your thermistor, instead of being an amount of light, it's pretty much going to be temperature. Okay, so examples of thermistors, they're used in everyday appliances, such as, because you could get asked an exam, fire alarms. When it gets really, really hot, of course, then that will set off the fire alarm, okay, because the resistance will then decrease. So the resistance, if you like, reduces the moment the fire alarm can feel the heat increasing, hence why it will set it off. They're also used in ovens as well, if the oven gets really, really hot. They're using refrigerators as well. So your refrigerator should, of course, be, around about 5 degrees or below. And if it doesn't, so if your door is left open, for example, you may have a fridge that sets off like a little beep or like a little alarm, and it will go off. That will tell you, of course, that the temperature has increased and you need to close the fridge. Okay. And lastly, LED. So LED is pretty much a component. It's light emitting diode, okay, shortened for LED. So they're used in lamps. They produce light when current flows through them in the forward direction. They use smaller current though than any types of normal lighting. So your normal light bulbs use like your halogen light bulbs, they're not very energy efficient, but LEDs are. So you'll notice where you can get LED lights where they can last for ages and they don't actually go off very quickly. They can last for such a long time because they use such a small amount of current. And people nowadays are using them. They're much more modern. All right. So they're used for lots of different applications: lighting, art lighting, outdoor lighting. They're used in cars. They're used in signages. They're very, very common to use these days. And basically, all that's happening there is that light is produced when the current's flowing through it, and it's in the forward direction. So if you see this symbol here, you should know that a diode is this symbol without the arrows. That's your normal diode. However, LED is a type of diode, meaning it can only go in a forward direction, one direction. And for an LED symbol, you've got the arrows. Just think of the arrows meaning light is emitting from the actual component. Okay, so that concludes our session on IV components and graphs. Please do like my page and check out my other videos as well on SAM Science Physics. There is also a video for SAM Science Biology, which I've started to begin to do. So please do check out those videos. So that's SAM Science Biology, where I'll start to put on some biology content as well.